We are still talking about surds, which are basically roots that cannot be expressed as rational numbers, right? So, and in this video, we're looking at simplifying cube roots and higher roots. We've been talking about square roots for the most part, and then just to also tell us that it doesn't have to be only square roots. We can talk about surds are basically roots that cannot be expressed as rational numbers. So, so what's the outcome we expect? By the end of this lesson, you'll be able to understand cube roots and higher roots, recognize perfect cubes, use index or exponent notation correctly, and simplify expressions such as the cube root of 54, then generalize root simplification before square roots. Okay? Beyond square roots, generalize root simplification beyond square roots. That'll be one of our outcomes after this video. Okay, so first of all, understanding cube roots. A cube roots answers the question, what number multiplied by itself three times equals the given number? So the definition is that the cube root of A is equal to B, means that B times B times B is equal to A. So if I want to do it like I did the idea of square root the other time, so now the question we are asking ourselves here is that for cube roots, right? Cube roots. So the question is which number, which number multiplied by itself, multiplied by itself three times gives gives the number, right? Gives equals the given number, right? Equals the given number. Which number multiplied by itself three times gives the equals the given number, equals the given number. Okay. For instance, what what is the cube root? What is the cube root of 5, you know? So now try to answer the question. Let let A be the number. Let A be the number which when multiplied by itself, which when multiplied by itself three times gives 5, because you're looking for the cube root of 5. So that means that A times A is equal to 5. So that means that A raised to power 3 is equal to 5. So we need to find A now. So to find that A, we need to get rid of the power. And to get rid of power, you need to take the roots. So to get rid of a raised to power 3, one thing we need to do is to raise a to power 1 over 3 so that 3 can cancel 3. And then we have 5 raised to power 1 over 3 also. So that a on its own now is 5 raised to power 1 over 3. And 5 raised to power 1 over 3 simply means the cube root of 5. So it means that it is the cube root of 5 multiplied by itself three times that will give us 5, basically. So if you want to check that, so since a is 3 cube root of 5 now, so it means we have cube root of 5 multiplied by cube root of 5 multiplied by cube root of 5. And that is the same thing as 5 raised by 1 over 3 times 5 raised by 1 over 3 times 5 raised by 1 over 3. And from the law of indices, that means you have 5 raised by 1 over 3 plus 1 over 3 plus 1 over 3. Because from the law of indices, you can add the powers when you're multiplying numbers like this. So you have 5 raised by 3 over 3. That means 5 raised to power 1, and that is simply 5. Okay, so that means it is true that the cube root of 5 is the number you multiply by itself three times to get 5. So that's like a very elaborate way of explaining a simple thing. All right, so we talk about examples of cube roots now. Cube root of 8 is 2 because 2 raised power 3 is 8. Cube root of 27 is 3 because 3 raised power 3 is 27. Cube root of 64 is 4 because 4 raised power 3 is 64. And then we talk about the idea of perfect cubes. A perfect cube is a number that can be written as n cube. So any number that you can write as n cube is a perfect cube. So let's look at the first 10 perfect cubes like this. I mean, talking about natural numbers. 1 raised power 3 is 1, 2 raised power 3 is 8, 3 raised power 3 27, 4 raised power 3 64, 5 raised power 3, that's 5 times 5 times 5, that's 125, 6 raised power 3 216, 7 raised power 3 343, 8 raised power 3 512, 9 raised power 3 729, and 10 raised power 3, that's 1000. So these are common perfect cubes that we'll encounter usually. So, and then talking about the index notation, or what you call the exponent notation, instead of writing 2 times 2 times 2, we can write 2 raised power 3. So in the vocabulary is such that 2 is the base, 3 is the index, or what you call the exponent. Then the exponent tells how many times the base is multiplied. So the exponent tells us you're multiplying 2 by itself 3 times. Now, when we're dealing with square roots, right, we're interested in whatever raised to power 2, because that is where that gives us the picture of what we are going to get if you are looking for square roots. Okay, so the important rule is that the cube root of a raised power 3 is equal to a. An example of that is that the cube root of 5 raised power 3 is equal to 5. That's because roots and powers are inverse operations. That was the kind of thing I demonstrated, here just now, you know. So, for instance, imagine that you have the cube root of a raised power 3. So that's the same thing as a raised power 3. Cube root means 1 raised power 3. So that means you have a raised power 3 cancels out. So you have a raised power 1, which is equal to a, like that. So the cube root of a cube is equal to a. So we move on. So root cancels power, power cancels root. Just like natural log cancels exponent, and vice versa, so to speak. So 7.4, simplifying cube roots now. The method, you factor the number. To simplify cube roots, you factor the number just like we did with square roots, and then you find the perfect cube factors and separate the cube roots, and then you can simplify. For instance, you have cube roots of 54. So for prime factorization, 54 is 2 times 27, and 27 is 3 raised power 3. So you have 54 times 2 raised power 3. And at the end of the day, you take the cube root of 54, that's cube root of 2 times 3 raised power 7. And, from this side, from so you separate the perfect cube now. Take cube root of 3 raised by 3, that'll be 3. Then cube root of 2, that remains, that's irrational. So at the end of the day, you have cube root of 54 to be 3, cube root of 2. I've done this before, so in a previous video. That's why I'm not bothering to do this. But I'm going to do this next one on the worksheet. So simplify cube root of 128. So first express as the power of 2, and you have all this. The answer ends up being 4 cube roots of 2. But let's go ahead and do it on the worksheet. Cube root of 128 is what we need to do now. Cube root of 128. So imagine I have cube roots of 128. So let's factor 128. So that's 264, 2, that's 32, 2, 16, 2 again, 8, 2, 4, 2 in 4, 2, 2 into 1. Okay, that's a lot, right? So that we have 128 to be equal to 2 times 2 times 2 times 2 times 2 times 2. That's 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's what that is. So that means we have, because we are interested in cube roots now. When we're interested in square roots, I was taking them in twos. But here we're interested in cube roots. So you take them in threes. 2 raised power 2, 2 times 2 times 2, 2 times 2 times 2. So because we are interested in cube roots, so you can then write this as 2 raised power 3 times 2 raised power 3 times 2. Okay? So that now the cube root of 128 is equal to cube root of 2 raised power 3 times cube root of 2 raised power 3 times cube root of 2. So of course, for just like for square, one of this we just answer because cube will cancel this if you like. Or you can just write out 2 times 2 times cube root of 2. Don't forget that cube root of 2 is not the same thing as 3 root 2. They are totally different. This 3 is inside that cage. So please pay attention to that. So here now 2 times 2 is 4. So you have 4 cube roots of 2. That's the cube root of 128 right there. Okay. Now, the grouping rule now. So we have general grouping rules that we've seen for 2 and 3. So for cube roots, group factors in threes. Each group of 3 comes out as one factor, just like what we've done here. So each group of 2 raised power 3 produces 1, 2 when you find the cube roots. So this 2 raised power 3 gives 1, 2 raised power 3 gives another one since we're looking for cube roots. So for square roots, group in twos, cube roots, group in fours, group in threes rather. For fourth root, group in fours. For nth root, group in n's, like this. So you can then talk about higher roots. Like we can extend this idea to higher roots. For fourth root, now we have fourth root of a, fifth root, or fifth root, we have fifth root of a, nth root, we have nth root of a. So imagine now that we need to find the we need to find the fourth root of 180. Of 80 rather. So you have to factorize. That's 16 times 5. That's 2 raised to power 4. So, and then you write 4th root of 80 is 4th root of 2 raised to power 4 times 5. And the 4th root of 2 raised to power 4 is 2. The final answer is 2 times 4th root of 5. So if I go over there and do this, 4th root of 80. Okay. So for 4th root of 80 now, so I need 4th root of 80. So we know 80 is 16 times 5. So that is 2 times 2 times 2 times 2. That's 16 times 5. And that is 2 raised to power 4 times 5. Okay? So 4th root of 80 is equal to 4th root of 2 raised to power 4 times 4th root of 5. So, and 4th root of 2 raised to power 4 is actually 2 times 4th root of 5. So that means we have 2 4th roots of 5. And that's just what we get for that. Okay. So we group it in fours like that because we are interested in the fourth root. Then we talk about negative numbers and cube roots. So cube roots of negative numbers are real numbers. Square roots of negative numbers are not, they are complex numbers. They cannot, they are complex numbers. They are not real, right? So, but for cube roots of negative numbers are real numbers. For instance, the cube root of -8 is equal to -2 because -2 times -2 times -2 is equal to -8, like that, right? Because we know that -2 raised to power 3 is actually -2 times -2 times -2. So that's minus times minus plus, plus times minus minus, 2 times 2, 4, 4 times 2, 8. So that's the deal there. -2 raised to power 3 is -8, like that. So, and then we talk about general rule for simplifying higher roots. So the general rule is that the nth root of a raised to power n times b gives so this, because a raised to power n, nth root of a raised to power n will give us a, then times the nth root of b. So this rule works for square roots, cube roots, and all higher roots. So generally speaking, we say that the nth root, okay, the nth root, the nth root of a raised to power n, I want to make sure that's not looking like n root something. So the nth root of a raised to power n multiplied by b is simply a multiplied by the nth root of b, generally. So that works for any kind of roots you might be considering. Okay, so let's look at the practice problems in this case. Okay, I think I'll do cube roots of, okay, there are 3 groups here. We have cube roots, fourth roots, and fifth roots. So I'll do one in each case. So let me go for cube root of 686. So let's go 686, cube root of 686. So for the cube root of 686 now, so let's factorize first. 686, we have 2, that is 343. Okay, and clearly the next thing is 7. 7 goes there 49 times, and 7 again, 7 times, 7 one time. So that tells us that that 686, or better still, let me just do it straight. The cube root of 686 is equal to the cube root of 2 times 7 times 7 times 7. That's cube root, don't forget. So that's now cube root of 2 times 7 raised to power 3. So that means we can then have cube roots of 2 multiplied by cube roots of 7 raised to power 3. And because this is 7 raised to power 3, so this is going to produce just 7. Okay, so this is equal to cube roots of 2 multiplied by 7. And then the final result is 7 cube roots of 2, like that. Okay, so we go for the fourth roots. Let me pick one. For the fourth roots now, let me pick 320. It's fourth root of 320. Fourth root of 320. So let's see how that goes. So we have the fourth root of 320. So that's 320. So 2 goes, that's 160. 2 goes, that's 80. 2 goes, that's 40. 2 goes, that's 20. 2 goes, that's 10. 2 goes, that's 5. Okay. And 5 goes, that's 1. So what do we have? How many twos? 1, 2, 3, 4, 5, 6. That's 64 times 5, which makes sense. So fourth root of 320 is equal to um, fourth root of 2 times 2 times 2 times 2 times 5. So that means we have fourth root of 2 raised to power 4 times 5. So that means we have fourth root of 2 raised to power 4 times fourth root of 5. So fourth root of 2 raised to power 4 is simply 2. Then fourth root of 5 is irrational, like that. So that's 2 fourth root of 5. Okay, lastly, let's go for um, fifth roots. So for fifth roots now, I'll pick I'll pick the last one, 2500. So 2500 like this, 2500, fifth root of 2500. Okay, so fifth root of 2500. So first the factors, 2500, 2, that's 1250, 2 again, that is 6. Hope that's fine. 2 in 2, 1, 2 in 5, 2, then 2 in 10, 5. Okay, 2 in 12, 6, 2 in 5 is 2, 2 in 20, 2 in 10 is 5. Okay, so now 5 can go. 5 in 6 is 1, 5 in 12 is 2, that's 1, 2, 5. 5 again, 5 in 12 is 2, 5 in 25 is 5, then 5 in 25 is 5, and lastly we have 5 in 5, 1. I hope that works. So this is 4 times 1, 2, 3, 4. 25 times 25, that's 125. 125 times 2. This is 25 times 25. Or better still, this is 10 times 10, 100, 100 times 25. Okay, that works. So we have fifth root, fifth root of 2500. That's fifth root of, we have 1, 2, 3, 4. Okay, I think this is just going to remain the way it is. So this is 2 times 2 times 5 times 5 times 5 times 5. There are only 4 fives, right? Because this is 10, 10. That's 100 times 25, 2500. So we can't break this down further. So it just remains the way it is. So that is fifth root of 2500. It can be broken down. We don't have a fifth root of that, because if we have if we have uh like 5 raised to power 5, you know, will be it will be out of the league here. So let me see what that looks like. 5 raised to power 5. So 5, checking 5 raised to power 5. 5 raised to power 5. That's 3125. Okay. So I mean this doesn't, so we can't simplify it further. That's what we have to do for this. So we just leave it the way it is. No further simplification is possible. Okay. So no further simplification is possible. So we can remark that no further simplification. No further simplification. So, and then that brings us to the end of this video talking about higher roots, cube roots, fourth roots, and fifth roots, and so on and so forth. So we just know that for square roots, we take pairs of the prime factors, and for cube roots, we take triples, we take them in threes. For cube roots, fourth roots, we take them in fours, and for fifth roots, we take them in fives. So with this, I come to the end of this interesting video. Let me know how helpful this is for you. And if there's something else like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, why not? Go ahead and subscribe right away. Hit the notification bell so you can always get alerted each time a new video is released. Okay. Having done that, you can also become a member of the channel by clicking on join. By clicking on join. And then you can when you do that, you have access to special privileges like getting to see some videos first, or some videos are just made for you as a member, or you can request for PDF copies of my notes. We can also hang out together to discuss whatever interests you on this channel. Before I go, I want to do this 16 for fifth truths so I can at least have one case where it works. So fifth truth of 64, right? Fifth truth of 64. So fifth root of 64. So we know 64 is uh 2 raised to power 6. So that's 2 raised to power, that's 2 times 2 times 2 times 2 times 2. 1, 2, 3. That's 2 in 6 places. So we need the fifth root of this, right? So that'll be square root of, that's the fifth root rather, of 2 raised to power 5 times 2, because there are two sixes. I mean 6 twos, right? So we then have fifth root of 2 raised to power 5 times fifth root of 2. Okay? So fifth root of 2 raised to power 5 is now 2 times fifth root of 2. So at the end of the day, we have that to be 2 multiplied by the fifth root of 2. Okay? So that can actually work. All right. So let me know how helpful this is for you. Um, already. And of course, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. This playlist on sorts continue. We're going to be talking about simplification, maybe sort operations, addition, subtraction, multiplication, division, and things like that. So be on the lookout for this. Bye.